This question will make you dance in joy. We are given a triangle that is completely inscribed inside a circle, whose center is at this point. As you can see in this figure, the sides of this blue triangle are 13, 14, and 15 units. And our goal is to calculate the radius of this circle. This circle is also known as a circumcircle. So, can you solve it? Okay, let's start solving. The very first thing we will do is drop a perpendicular from this vertex straight down to this base, like this. Next, we will assume that the length of this segment is equal to x units, and the length of the perpendicular is equal to h. Now we already know that the total base is 14 units long. Since this is x, that means the remaining part must be 14 minus x, right? Okay, now focus on this small right triangle. This triangle has sides x, h, and 13, where 13 is the hypotenuse. By using the famous Pythagoras theorem, we can write h square plus x square equals 13 square, right? 13 square gives us 169. So we can rearrange this to get h square equals 169 minus x square. Nice! Now let's look at the other small right triangle. This triangle has sides 14 minus x, h, and 15, where 15 is the hypotenuse. Applying the same Pythagoras theorem again, we can write h square plus 14 minus x, whole square equals 15 square. 15 square gives us 225. Then we will expand 14 minus x square using the a minus b whole square identity, which is first term square, minus 2 times first term times second term plus second term square. That means we get 196 minus 28x plus x square. Let's move the terms around to isolate h square. That gives us h square equals 225 minus 196 plus 28x minus x square. This simplifies to 29 plus 28x minus x squared. Now we have two equations for h squared. Since both have the same left-hand side, we can equate the right-hand sides. Therefore, 169 minus x square equals 29 plus 28x minus x square. Hey, the negative x square on both sides cancels out beautifully. So now we are left with 169 equals 29 plus 28x. Subtract 29 from both sides, and we get 140 equals 28x. Dividing both sides by 28 gives x equal to 5. Wow! Awesome! Next, we can plug this value of x equals 5 back into this equation to find h. We get h square equals 169 minus 25. That gives us 144. Taking the square root of both sides gives h equals 12. Great. Now let's move on to the final part. We will draw a line from this vertex, passing through the center of the circle, and extending to meet the circle again, on the opposite side at this point. This line is the diameter of the circle, which is twice the value of the radius. Label it as 2 times r, where r is the radius of this circle. Now, here comes the magic. Connect this vertex with this point. What do you think this angle will be? Recall a very important theorem in circles called the Thales theorem. It says that if a triangle is drawn in a circle such that one of its sides is a diameter, then the angle opposite that side is a right angle. That means this angle is a right angle. Next, we will use another very amazing theorem called the inscribed angle theorem, which says that angles that intercept the same arc are equal. Look at this angle. It subtends this arc of the circle. Then look at this angle. Hey, it also subtends this arc of the circle. So both these angles are equal. Now look at these two right triangles. They both have a right angle, and also both these angles are equal. So both the triangles are similar. Therefore, by the property of similar triangles, the ratio of corresponding sides will be equal. Therefore, this side h, or 12 over hypotenuse, or 13, equals this side, or 15 over hypotenuse, or 2 times r. Take r this side, and 13 over 12 this side, to get r equals this. This gives us 65 divided by 8, which is equal to 8.125 units. And there we go. So good!